Okay, so Canvas is apparently not working today. Fantastic, that's great. I didn't stay up later last night working on this study guide, but whatever, I'm not bitter about it. Just had to frantically remake the whole thing and delete my old study guide review video because it wasn't going to work. So, whatever. Here's the plan for today. The study guide is going to be a PDF. I'm going to try to put it on Canvas, and I'm also going to put it in like a Google Doc and like put it into our Zoom meeting. I am still going to have that, but in case you're watching this anytime other than today, just know that Canvas for whatever reason wasn't working today, so that's a thing. Anyways, the answer key, if you did the whole thing already and just want to skip to the answer key, then that's going to be in like the last 1 minute of this video. The rest of it, we're going to, I'll give you a moment to pause, and then I'll work through a problem, give you a moment to pause, work through a problem, and so on and so on. So here we go. If you want, you could even just work along with me here. That would be my recommendation. But anyways, number one, which expression is equivalent to 32? We look at the first option, 4 squared times 4 to the first power. That's the same as 4 to the third power. We've done this a couple of times in class before, and you already know that is 4 times 4, which is 16, times 4 again, which is 64, so it's not A. For B, you could probably tell this was the correct answer because I had to retype it because some of these are completely illegible. But the reason we know it's B is this would be written as 2 to the third power over 2 to the negative second power. And we know that's the quotient rule. We are going to be basically just lining these up and subtracting my exponents. That's going to be 3 minus negative 2. So 3 minus negative 2 is actually positive 5. Remember that when you subtract a negative, you are basically adding. And 2 to the fifth power, that is 2 times 2, which is 4. Well, I'll write it out here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that is my correct answer. For number 2, this one I also had to rewrite. 2 to the seventh power over 2 to the negative third power. So same thing, we already know. With one exponent directly above the other, we are basically subtracting those. So 7 minus negative 3. Same thing that happened up here, we're basically adding those two numbers, which will give us 2 to the 10th power, which is C. For number 3, this one was a little bit more difficult. For this problem, we have 8 squared to the second power over 2 to the third to the second power. Now, first of all, you would want to go ahead and take care of these first. This is my exponential rule, meaning I'm not going to add those two numbers, although it doesn't matter for the top. I'm going to be multiplying them. So this is 8 to the 2 times 2 power. That would be 8 to the fourth. Down here, we've got 2 to the third times 2. So that'd be 3 times 2, that's going to be 6. Okay, so 2 to the sixth power, we can kind of piece together what that's going to be based on up here. That would be 64 in the denominator. 8 to the fourth power is going to be quite a bit larger. That would be, let's see, 64. That'd basically be 64 times 64. And you should know the first 4 problems are really the longest problems on the whole paper. 64 times 64. I'm hoping this is right. I might have mistyped those because if you thought this problem right here was hard to see, it's worse on the original. So let's see. 64 times 64, that would be 16. That'd be 25. That would be, well, do you know what? Hang on a second. We said it's going to be 64 times 64. Take a shortcut here. One of those would cancel out, which would leave us just 64 on top. So whatever answer I'm going to get up here, and I'll go ahead and finish it just for the sake of proving my point, be 38, 6, 9, 0, carry the 1, 4, 4,096. If I had 4,096 and divided it by 64, I guarantee you the answer will be 64. So, but that is a shortcut you can take. You can get it down to the point where you have 64 times 64 over 64. Naturally, one of those would cancel out, leaving you with just 64 on top. So a little shortcut you could take there. For number 4, what's the value of this expression? This expression looks like a nightmare because it kind of is. There will be one absurdly hard problem that I'll be giving you guys, so watch out for a problem like this. Anyways, for this, I'm going to try to rewrite it down here so that way it isn't as jumbled, but I'll go ahead and tell you right now, that is going to be a 2, that is supposed to be a 4, that I believe is a 3, and that I believe is a 3. 2 and a 3. Quite sure that those are the numbers. Not 100% sure, but I'm pretty sure. So we already know those are going to multiply, those are going to multiply, so let's just take care of pairing those numbers up for now. So on the top, 3 to the 2 times 4, that'd be 8. So we have 3 to the 8th times 2, 3 times 3, that's 9. Down below we have 9, 2 times 3 is 6. 4, 2 times 3 is also 6. All right, so this is going to be a problem. This is just going to be one of those long brute force problems. What we're going to want to do is we're going to start by seeing if we can maybe simplify some of this. So let's just look at my, when I say we're going to simplify this, we're going to write this out. We're not going to solve it because it's going to take a minute, but we are going to write some of this out and try to simplify parts of it. So we are going to need a rather long line, unfortunately, because we're going to have 8 3s. That's 5, that's 6, that's 7, that's 8. Times there's going to be 9 2s, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Then we're going to have a bunch of 9s. We're going to have 6 of them, but I'm going to put them over here by these 3s. 3, 4, 5, 6. Whoops. Accidentally said or wrote what I said. Okay. We also have 6 4s. 1, 2, 3, 4, 5, 6. Do you kind of see what I'm trying to do? I'm trying to pair these up, so kind of like what I did up here where I just crossed out 2 64s. Well, 3 times 3 would equal 9, right? So this right here is the equivalent of one of these, which means they cancel out. Okay, so that's two less numbers to deal with up top and one less number to deal with on the bottom. You could theoretically go ahead and do 3 to the 8th power and 2 to the 9th power and then multiply them and start dividing, but that will take a century. Writing it out and then crossing out these values will help shorten your workload immensely. So we'll just keep pairing these up. 2 more 3s, 1 more 9. 2 more 3s, 1 more 9. 2 more 3s, 1 more 9. Okay, my 3s are all gone, so these would all come out to be a bunch of 1s. And then so we still have 9 times 9 there, so that's not going to work. 2 times 2 equals 4. 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 So on the bottom, we still do have some numbers left. So let's see what we can do about this. And I'm actually starting to look at this problem and realizing the correct answer to this one isn't going to be there, but that's okay. So for the top, what numbers remain? We have 1 times 1 times 1. We don't need any of those ones. All we need is the 2. 1 times 2 basically goes up top. And for the bottom, we have 9 times 9 times 4 times 4. A much more reasonable number on the bottom. Those two will give me 81. Those two numbers give me 16. So 81 times 16 will be the number that goes on the bottom. Okay. And remember, this is not supposed to be calculator active. Be 1,296 over under 2. We could simplify that. And again, I'm letting you know, I must have miswrote one of those numbers at some point because the correct answer isn't there, but we're not going to redo that. Okay, so let's see. Those are definitely both divisible by 2. I know the numerator is going to be 1. Take this number and divide it by 2. Do that way off to the side over here. 12, 9, 6. Divide by 2. 2 goes into 1. No. Goes into 12 6 times. Carry down by 9. Goes into that 4 times. And carry that down. Goes into that 8 times. 648. So I'll probably, by the time you guys see this, one of those answer choices will actually say 1 over 648. It's probably going to be answer choice B. So yeah, that's going to be number 4. Okay? Number 4, definitely the hardest problem on this whole thing, as far as I can tell. Let's see now. I don't have much more time to record this. That's not good. For number 5. Which model best represents the square root of 196? So what two numbers would multiply to get 196? It's not 7 times 7. C and D both are not going to have the same two numbers, so they're automatically wrong. It's going to be 14 times 14, which would be B. For number 6, let's see, we're trying to solve the square root of 121. So what two numbers multiply to get 121? That'd be 11 times 11. That's what we want for number 6. For number 7, in the equation, x to the third power equals 8. What could be the value of x? So it gives us some options, and those numbers are really small. Here's what those numbers say. Those numbers are all 3s. Okay, so we have the cubic root of 512, no. Cubic root of 64, no. Cubic root of 24, also no. Cubic root of 8, yes, because that would be the opposite of the third power. That's what we want. Okay, cubic root of 8 is going to equal, cubic root of 8 to the third power. Those two amounts would cancel out to give us 8. That's what we want for number 7. Let's move on to number 8. Actually, we're going to have to break this up into 2 videos. So this is going to be that's the first video. Second video will be a separate part. It'll be linked somewhere. But I'm out of time to record this part.